Good day, I'm Mike Mata, and today we're going to start Packet Dissection 101. We're going to go through the Datalink layer and show you the source, destination, and protocol type, and how we use that information to troubleshoot our networks. So I think in terms of the 4-layer internet model, I know you've all been beat up with the 7-layer OSI model, so I'm not even going to talk about it. When I think of frames, I think of the 4-layer internet model, which they architected when they architected IP. And that's what we're going to start with, is the local network layer, if you will, frames, where we're moving frames from NIC addresses or Ethernet addresses, since we don't have to deal with any other forms of networks today. What rides on top of the local network in this case is the packet layer, if you will, or the network. We're moving packets from IP addresses, or I like to think of them as protocol addresses. And what rides on top of the network layer is the transport layer, and we're either transporting segments of the message in a connection-oriented protocol like TCP, or connectionless like UDP, and those are the only two we have to deal with today. And again, what starts all this fun and magic is the application. So we fire up some application, whether that be voice, whether that be video, whether that be, your browser, Internet Explorer, Chrome, Firefox, whatever, and we type in www dot something. All that starts this process. So once we have the frame, if you think about decoding the frame now using your favorite analyzer, either Observer or Wireshark, starts with the DLC header, the Datalink layer, or sometimes known as the MAC layer, Media Access Control. So that's our first 14 bytes of the frame. Sometimes new protocols today, like spanning tree, that's not really a new protocol, but you'll see that in your environment. Spanning tree, Cisco Discovery Protocol, those newer types of protocols use LLC headers, and we'll talk about that in a future segment. But today we're just going to focus on the Datalink layer, 14 bytes, and what rides on top of that, the network or IP header, and then the transport header. So the network layer is transporting TCP or UDP, and I always kind of think of the knee bones connected to the shin bone. And then what rides on top of the transport layer, the application. And again, that can be voice, video, web, database, whatever the application is, homegrown, doesn't really matter. It all plays by the rules to move it across our network in frames. So we're going to focus today on the first 14 bytes, or the DLC header, and then we'll continue our process with the IP header and the TCP header in the application. So the first 14 bytes, Datalink layer, and then the last 4 protects the frame, if you will, or the CRC. It's also known as the frame check sequence, or CRC is cyclical redundancy check. And this is once we move the frame across the network, then the other end calculates the CRC and compares it to what the source put in. And if the two numbers match, it's a good frame. Then you hand it up the stack based on the protocol field. And if the two numbers don't match, then the receiver discards that frame. And then, now something else has to happen. TCP has to retransmit it if we're using connection oriented, or it's just lost. It's just thrown away if we're using UDP or connectionless. So again, the Datalink layer, we're carrying IP headers, minimum 20 bytes, maximum 60 bytes. IP can transport either connection-oriented, TCP, minimum 20 byte header to maximum 60, or connectionless, UDP, fixed 8 byte header. And then the application could be voice, for instance. If we're doing UDP, we'd be carrying RTP, real-time protocol, as the application layer. If we're doing TCP, then usually that would be something like HTTP or SQL, or any homegrown application that needs connection-oriented capabilities. So let's get into the packet information as far as how this is displayed and how we use it for troubleshooting. Okay, in Wireshark, for instance, we see, if we highlight the Ethernet 2, here is our Ethernet header, and you'll notice in the hex window it shows the first 14 bytes. So that's what we just talked about. That's our Datalink layer header, and it consists of a source, who is the frame coming from, and in this case it gives us both the 6-byte MAC address, and it gives us the first 3 bytes manufacturer ID and the last 3 byte unique. So this particular frame is coming from a source of an Intel NIC, and it's going to the destination address of a Hewlett Packard NIC. And again, it has to be on a different subnet based on the IP addresses of 10. and 65. So we can presume that HP NIC is the MAC address of our default gateway. So in order to talk off of our local subnet, we're sending this particular frame to the MAC address of the router. And in this case, the router is an HP, at least has an HP NIC. Seeing that same information in Observer, again, we can see the source address and destination address. So we see here the source MAC address is 8853.2E0659D7, or once again, you see the same. Intel, it's coming from an Intel NIC and going to the destination of an HP NIC. So once again, HP NIC is the default gateway. And you'll notice then the protocol field. So this says this particular DLC header or MAC header, however you want to view this, is transporting the next upper layer protocol that we're carrying in this frame is IP. And that protocol field is the ether type of 0800. And that defines the next upper layer protocol as IP. So there's our first 14 bytes that makes up the Datalink layer. And once again, you can look at your ARP cache simply by typing in ARP space -A, and you should be able to see the MAC addresses of your local machine, and the default gateway should be in there as well. So if you're talking to local devices on your local subnet, then you will see frames going from your local NIC MAC address to the server's local MAC address, or you'll see frames going from, the client or your NIC to the default gateway's MAC address. So that's really pretty much all we use the Datalink layer for. I hope that was helpful, and thanks for listening.